Hello everyone, welcome back to MGF1106. In this video, we will continue exploring geometry. And in the last video, I already introduced some geometry entity, angle and sine. And as long as we have angle and sine, we can create some geometric shape. And this geometric shape, we call it polygon. Okay, so in this video I will be talking about polygon. We will be learning how to calculate the sum of the angle, the interior angle of the polygon, and we talk about some property when we compare between two polygons. Okay, so let's get started. Okay, a polygon. Oops, wrong one. Polygon. Alright, so what does it mean by polygon? Poly mean many. Poly mean many. Gon it mean angle. So actually polygon is just a geometric shape, and this geometric shape is the closed one. It's a closed geometric shape. So polygon mean closed geometric figure or geometric shape. Okay, or figure. One of the geometry shape you guys already learned in middle school, maybe high school, is the triangle. Right? Triangle. Tri means three. Okay, angle. I mean, so this geometry has to contain three sine, three angle. Or you learn quadrilateral. Quadrilateral is that is 4 sine 4 angle, right? Or we have a square or rectangle. We have 4 sine and 4 angle. All of them is the polygon. Okay, and actually most of the time we talk about a triangle. And triangle, there are few different type of triangle. We have isosceles, right? So we know isosceles is also the polygon over here. And an isosceles triangle is when you have two sides equal to each other, and the base angle is also congruent to each other. Then we have equilateral. Equilateral triangle. So equilateral triangle is a triangle when you have three sides congruent to each other. Okay. So three sides congruent to each other, and three angle congruent to each other. Okay. So or we have some a very familiar triangle we already learned is the right triangle. So right triangle, we have one of the sides 90 degree, right? And we have some random scaling triangle. This means it's not really special. It's just we have a three side and three angles, so we have something like this. Or we have obtuse triangle. There's something look like that. Okay, so all of the shape over here we can call the polygon. Poly mean many, so we have three angle over here. Or we have a square, right? We have square, so we have a square. You have all of them is 90 degree over here, and all the sides congruent to each other. And we have rectangle. Rectangle is something look like this, right? Okay. Okay, just right. It's rectangle, something look like this. So we have this side equal to each other, and the side over here equal to each other, and angle over here is also 90 degrees. Okay. Okay, this is a very common geometry shape you guys already know, and you see this, so in application so many times already. Of course, there's some polygon that contain more than three sides or four sides. Some polygon it could be something like this. Okay. Okay. All right. And you see that over here, how many angles we have? So we have 1, 2, 3, 4, 5. So we have 6 angle over here, and we have 1, 2, 3, 4, 5, 6. We have 6 sides, and all the sides not congruent to each other. Neither does the angle, right? So this is also the polygon. This is also the polygon. Okay. So the polygon is just a closed figure again. It's just a closed figure, and create by you can create all the polygon over here by side and angle, and all the side can be congruent or doesn't have to be congruent. Okay. Okay. Or you see that you have a stop sign, right? The stop sign look like this, and this is also a polygon. Okay, so we have stop sign look like that, right? Okay, so all stop sign equal to each other. Uh, okay. Oh, remember we have in DC area we have in Pennsylvania we have a pentagon, right? Pentagon. I mean that we have 5 side. We have 5 side congruent to each other and 5 angle congruent to each other. Okay. Okay, something like that, right? So we have this. So there you go. So all of them, all of this over here, is all the shape over here we call the polygon. Now you see the angle inside over here we call the interior angle. We can find the sum of the interior angle by using the formula, and the formula is S equal to n minus 2 multiplied by 180 degree. So n in this case is represent the number of side. N is just represent the number of side in the polygon. For example, over here we have pentagon. We have 5 sides, so n over here will be 5. Okay, and we have for example over here we have 6 sides, so n will be 6, and we can find the sum of all the sum of the interior angle of any polygon. Okay, let me give you the example. This is not really that hard. For example, we have 6 sides, so we have 6 angles. So we have a hexagon 1, 2, 3, 4, 5, 6 over here. Okay, and we can find the sum of the hexagon by s equal to 6 minus 2 times 180. So give you 6 minus 2 give you 4 times 180. So give you what? 3. So 180 multiplied by 2 give you 360. 360 multiplied by 6 give you 720 degrees. So all the sum of all the measure of the angle over here will be 720 degrees, and you can verify the formula very easily. To think about, you have 4 angle, right? So n equal 4 minus 2 give you 2 times 180 is give you 360 degrees. It means that all the sum of all the square or rectangle or any quadrilateral shape at the sum of all its interior will be 360 degrees. And think about it, all the triangle, the sum will be 180. You guys already know that because you think about it, right? We put n equal 3, right? So 3 minus 1 will be 1. 1 times 180 will be 180. Okay, so all the sum of interior angle will be for the triangle will be 180. Will be 180, and for the quadrilateral shape will be 360 degrees. Okay, and you can use this again. You can use this formula as long as you know the number of sides. You can find the sum of all interior angle of any polygon. Okay. Now, on the next part of our our video here, I want to talk about a similarity property of the polygon. So I'm gonna put this at the first part right here, but actually the second part. So I would like to talk about the similarity property. Okay, so what does it mean by similarity? When you have two polygon and they have the same shape. It could be bigger or smaller, but as long as they have the same shape, they have the same angle, then we can say that they are similar to each other. Or mathematically, you can say that as long as you have the proportion between the corresponding side of two polygon, then you can determine that this is similar to each other. So actually similarity over here, it imply, okay, this is similarity is imply the proportion. Okay, it imply the proportion among between okay, corresponding side. Okay, now let me explain it further by giving you two similar polygon. Let's say I have two triangle. Okay, let's say I have two triangle. What if I have a triangle over here? I have triangle, just a random triangle. Okay, that's a scaling one. Triangle ABC. Okay, and I have a bigger triangle ABC, but it is same shape, but it's just bigger. So I zoom triangle ABC. I zoom in and I make a bigger one. So I have something like this. Okay, so I'm going to call this A prime, B prime, and C prime. And I say that these two triangle ABC and triangle A prime, B prime, C prime, I say that they are similar to each other, and the symbol for similarity is this one right here. Okay, it's like it's a tilde. It's a tilde. Um, it's tilde symbol. Okay. I just want to check if this in the textbook they're using that symbol or not. Uh, or they don't use that symbol. However, I just want to introduce that to you just in case sometimes when you do the homework, they probably use that symbol in your homework. So this is tilde symbol. Okay, it's tilde. Okay, tilde. So this tilde symbol over here means similarity. So they have triangle here, similar to this triangle. And when you have similarity, you have proportion. Proportion what? But proportion between the side. So it means what? It means from here I can set up the ratio between the side, the corresponding side. You see that side AB over here, corresponding to side A prime B prime. Okay, I have first fraction and equal to AC over here corresponding to A prime C prime. Okay, and BC over here corresponding to B prime C prime. Okay, you can start with the bigger triangle first. Okay, or you can start with the smaller triangle first. However, if you start with the smaller triangle, then all the side must be on the top. Okay, so the AB over B prime, B prime. Okay, so I cannot switch the position right here. I cannot put A prime C prime on the top and AC at the bottom. Okay, because you already start with the smaller side. The smaller triangle. If you start with a bigger triangle, then everything on the side of the bigger triangle must be on the numerators. Okay. Okay. So remember that. Okay. Similarity imply proportion. If we have similarity, we have a proportion. Okay, and if we have proportion, think about it, we can go ahead and find the measure of the angle in the polygon easily. Now let me mm, uh I forgot to mention about so over here we talk about the ratio between the side. Um, we also, for similarity, we also have congruent angle. Okay, angle the angle must be congruent to each other, and again must be the corresponding angle must be congruent. So similarity imply proportion, and it imply uh, congruent congruent corresponding angle. Okay. Okay, so it means what? It means that over here you're gonna have angle A. Okay, measure of angle A is congruent to measure of angle A prime. The measure of angle B is congruent to measure angle B prime. Measure of angle C is also congruent to measure of angle C prime. Okay, so remember that. Okay. All right, now let me start with our first example. Let's see. Let's see we can use the proportion to calculate the measure of the sine or not. Okay, example number one. Okay. All right. Let's see. I can have something here. I don't know what is it showing here. I probably nope, not this one. I believe it should be this one. Okay, so I have an example like this. All right, so you see that I have a quadrilateral angle shape right here, and they say that it's similar to each other, and we want to calculate the x, y, and z. All right, so because they already say that it's similar to each other, so we can go ahead and set up proportion. Okay, we set up proportion between the side. Okay, so make sure that on the side corresponding, we should set up proportion. It must be corresponding to each other. So let's see how we do this. Okay, so we have this is 115. So it look like 18 over here corresponding to SR. 115 is look like 115 over here look like it is the Z. Okay. Okay. Right. Should be the Z over here because the okay, it could be this is 30. It's 18. So SR. Let me start with the smaller one first. So MN over MN is the bigger one. This is a bigger one. MN. Okay. So we have MN over SR. Okay. Well, I have to say that the shape over here is not quite. It's hard to determine that which one because so X over here over this one. Okay. So I set up 30 over 18. Oh, MN over 30, and over here I'm just gonna put x over. Because x will be this side, so x over 25. That is one of the proportion we have. Okay. Equal to 15 over y. There you go. Now we're gonna go ahead and find x and y. Okay, and the z is the angle. The z angle, of course, the z is 115 already. So measure of z will be 115. It's pretty obvious. We don't have to calculate anything. All right, so we know mn is 18, sr is 30. So I have this. Okay, now I'm gonna just go ahead and pick up this proportion. So for x value. Okay, so from here we have this. All right, we do go ahead and cross multiply, so we have 30x equal to 18 times 25. 18. Oops. Oh my god. There's no battery over here in my calculator. Let me see. I can. That is bad. I don't have battery. Uh, okay, so over here we have 450, and you divide by 30. You have so actually over here you 15. Okay, so x is 15. Now we can go ahead and grab this one and this one. We can go ahead and find y. So we have proportion 18 over 30 equal to 15 over y. So from here you have 18y equal to 30 times 15, which is give you 450. So 450 divided by 18. So you have y equal to 25. There you go. So you see the proportion is very important, right? Proportion it helps you to calculate the measure of the side easily. Okay. All right. Let's do another one. Let's see. Actually, I lost track over here. All right. Let's do this one. H2 over here. Example number 2. All right. So again, we have that these two shapes over here is similar to each other. Okay, they're similar to each other, and I want to calculate segment BC and CD and NP. Okay, so first of all we need to look. Okay, so we need to see which one, what side corresponding to each other. So look like we have 15 over here, and this one equal to that. So this is 118. So look like that EA over here corresponding to this. Okay, so we have the square right here. So we have QLM. So mean ABC. So if we go ahead and write a similarity, we will start with this one first. So you have QLM. Okay, then N, then P. Okay, and it's similar to so start by over here. We'll start with this one, and because the third letter is right at the 90-degree angle, so it's similar to A, B, C. D go with the N. D go with the N. See that 100 degree, and okay. All right, now we can go ahead and set up the ratio. So from here we can have okay, AB over AB go with QL, okay, equal to BC go with ML, MN go with MN go with CD, and oh, I'm sorry. So DC go first. See that? I mess up. So DC must go here. So DC go with DC go with MN. Okay. DC go with MN. Then ED AB, go with NP. Okay. Alright, now we go ahead and plug in the number. So we got AB, we don't know AB. We don't know AB. Do we know QL? We don't know QL either. Well, we know BC. We don't know BC either. BC we don't know. Do we know ML? Yes, 8. DC we don't know. MN 14. ED 9. And NP we don't know. Alright, so from here we want to find BC. I'm gonna go ahead and snap. We'll go ahead and grab this one right here. Oops. Well, there's a lot of things we don't know. A14, 15, EA, EA. Oh, we're missing something. EA and QP. So which is EA is 15, QP is 10. There you go. So we see that we can grab this one and this one right here to find BC. So BC over 8 equal to 15 over 10. So from here we can find BC easily. So 15 times 8 over 10, 120 over 10. So BC will be 12 unit. Okay. Now we go have find CD. CD. So I'm gonna pick this one over here. CD over 14 equal to 15 over 10. So we have 10 CD equal to 15 times 14 will be 210. So CD give you 21. Okay. And for C, we gotta find NP. So NP right over here. So we're gonna pick the last proportion. So you have 9 when the NP equal to 15 over 10. So you have 15 NP will be equal to 90. So NP will be equal to 6. There you go. Alright. Now we also want to find angle E and angle Q. I believe angle E should be easy. Angle E, because angle E over here corresponding to angle E, go with angle P. So angle E, measure of angle E is equal to, you see that E corresponds with P, so equal to the measure of angle P, and angle P is 113. Yeah, there you go. And the measure of angle Q, Q is equal to A is right here, so A is 12. There you go, 112. There you go. Okay. Now, in example number 3, let's see. Let's see, have something else. 1, 2. I don't know if I have it or not. Okay. Alright, so these two over here, they are also similar to each other. Okay. And this is B, A, B, C, D, E, F. Okay. Now I'm gonna go ahead and set up a portion. So first of all, let's see. So 70 to go with this one right over here. So we're gonna do A, B, C, D, similar to A prime, B prime, C prime, and D prime. So from here you can set up the proportion. So you can have AB over A prime, B prime, BC over B prime, C prime, CD over C prime D prime, and dA over D prime A prime. Now we already got these 10. A prime B prime we don't know. BC 11, B prime C prime we don't know. CD we don't know. C prime D prime we don't know. DA we don't know, but D prime A prime we do 9. So you see that we have only 3 information, and we want to find the length AD. So right here, so I feel like they are missing some information right here, because oh, I think this is not similar to, they are congruent. Oh, I think I messed up this. I don't think this problem is for the similarity property we're supposed to do. I'm sorry, I have to erase this because this should be congruent. This is for the next one. No, it's not for this. I picked the wrong example. So go ahead and erase this. This is not similarity. Okay. Let me erase it. Oops. It's not similarity, guys. I picked the wrong problem. That's why. Let me pick it again. Uh, uh, okay, so go ahead and delete this. Okay. Yeah, I picked the wrong problem. That's for, it's not for similarity property. Uh, no, this is maybe 4. Okay. All right. So this one over here is not. This is a general problem. This problem here is not. They didn't say anything about similarity anymore. So we're gonna use all the concept we learned so far to solve the question here. Okay. So we know this angle ABC over here is 125 degree here, and we know parallel. So we know if we have parallel, we have at least a few congruent angle. So we want to find angle GBC. GBC, where GBC? Where's G? GBC. So GBC is this one right here. We want to find this one. Okay. So we know that this is 125 degree. Okay. So in order to find GBC, is to take this is adjacent angle, flat one. This is called as a supplementary angle. So in order to find GBC is very easily. So measure of angle GBC could be 180 minus 125. Okay. So give you 55 degree. Okay, now B is DFE, DFE, DFE. So we want to find this one right here. So in order to find this, okay, let's see how it. So in order to find it, we can find this one right here, and this one is equal. This is parallel, so this is equal to that. So this is also 55. So 55 is right here. Okay, you see that parallel? Okay, so this equal to this interior angle, interior alternate angle, and this one is equal to this one because if it's also parallel. Yep, this is parallel to this, so this is equal to that. Okay. Yes. So this is 55. So in order to find EFE, okay, EFE, we're gonna take 180 minus minus 90 plus 55. Okay, plus 90. So minus 180. So this is give you 35 degrees. Okay. Then we want to find part C is the EDF. Okay, EDF. Oh, this is easy because we know that this is triangle. So measure of EDF will be 180 minus 90 plus 55. So this is also, this is give you so 35, I'm sorry. Okay, so this is give you 55. Oh, actually, you see that this look like this is parallel to each other because this will 90 degree here, so actually this is 55. Okay, you can think that way, or you can look at the triangle DFG over here, then we have this. Okay, and for part D, we want to find a measure of angle DC. Okay, DEC, which is this one right here. Okay, so DEC is this one right here. So we already have 90. Or you can look at this one. Actually, DC is 125. Because you see that this one and this one parallel to each other. Yeah, but I can calculate like this. You can add the 90 plus to the angle right here. Okay, this is the 55. So the 55. So this one will be 90 minus 55. It's 35. So right over here is 35. It's 35. So the whole thing will be 90 plus 35. 125. There you go. So the example 3 over here is nothing to do with similarity concept, but I want to use all the concept we learned so far in terms of the angle, parallel, so that we can solve this. Okay. Now the second property of the polygon I want to talk about is the congruent property. Okay, congruent property. Okay, so what does it mean by congruent? So a congruent, it mean we have two shapes, they congruent to each other, mean they don't there's one shape is not bigger or smaller than the other one. They exactly the same, and because they exactly the same, so it mean what it mean, all the side will be the same, everything will be the same. Okay, so let's say I have two triangle ABC, two polygon A prime, B prime, C prime, and I say that they are congruent to they're congruent to each other. So that is symbol for congruent. Then with the equal and tilde sign like that. In some textbook they just put like this. Okay, it's still congruent symbol. Then from here, it be congruent to each other. So triangle ABC congruent to triangle A prime, B prime, C prime. Then if it's congruent, then we have on the side congruent to each other correspondingly. So you have AB congruent to A prime, B prime, AC congruent to A prime C prime, BC congruent to B prime C prime, and the measure of angle A equal to measure of angle A prime, measure of angle B equal measure of angle B prime, measure of angle C equal measure of angle C prime. Okay, now it's gonna help us to solve the problem, which is the one I already erased it. So this is the problem. Okay. Alright, so oops. A B C D E F. Alright. So let's see how I can find A. So let's say that the two shapes over here congruent to each other. So we want to find AD. AD is congruent to A prime D prime. So AD will be 9 unit. Okay. AD will be 9 unit. Okay. And B, the length A prime B prime will be 10 unit. Okay, because congruent. Angle DAB. DAB. So DAB over here will be I guess we have to wait. DAB. Let's try to find this one. So B prime C prime. So D and B prime C prime. B prime C prime must be 11. Okay. E is BCD. So BCD is congruent to this one. So BCD will be 50 degree. Okay. And A prime, B prime, C prime, A prime, B prime, C prime will be 70 degree. And DAB, so this one will be so this one right here become congruent. So this is will be 50. Okay. So it mean what? It means that B prime, A prime, B prime. So in order to find angle DAB over here, we can use the property that the sum of the interior of quadrilateral quadrantal. I'm sorry, quadrantal is 360. So over here we can take 360 minus 70 plus 130 plus 50. I keep saying quadrilateral. It's quadrantal. Okay, because the fourth side. Okay, let me give you the answer. Okay. Alright, so I'm gonna stop right over here. That's all we need for this video. So in the next video we continue with the area and the volume. Okay, but for the congruent, I think that's all we need. Okay, so I'm gonna stop over here and I'll be seeing you next time.